Hello and welcome. We're going to be talking about Article 90 of the 2017 National Electrical Code, Article 90 being the introduction to the National Electrical Code. My name is Ryan Jackson. This is what I do for a living. I teach classes, I do consultations, write textbooks, expert witness testimony, things of that nature. So I'm kind of an electrical code nerd, if you will. If you want to get in touch with me, my email address is right there. Please feel free, ryanjackson618 at gmail.com. Let's go ahead and get started. So Article 90, as I mentioned, is the introduction to the NEC, and because it's the introduction, a lot of people tend to skip it, which I think is a mistake. Article 90 is not going to tell you anything about how to install wires, how to size conductors, grounding and bonding, how far apart your straps have to be for your conduit. It doesn't tell you anything like that. What Article 90 does is it tells us how the code works. It tells us when the code applies. It tells us why the code exists. And all of those are quite important and worth understanding. So we start with 90.1. The purpose of the NEC. And 90.1 has subsection A, and it says practical safeguarding. This is a sentence that, if you've been in the industry for very long, you've probably heard several times. It says the purpose of the code is the practical safeguarding of persons and property from the hazards that arise from the use of electricity. So it's there to prevent hazards, and really the two hazards that it's trying to address are electric shock and fire. And as you can see from the photograph here, this was an electrical fire. This is a picture that I took probably back in 2002, 2003. I was a young inspector and got a phone call from a fire marshal who asked me to come out and help him out with a fire investigation, which that in and of itself was somewhat unusual. You know, I figured, well, you're the fire guy, why are you calling me? And he said, well, I've got a fire, and quite frankly, I don't really believe my eyes, to be perfectly honest with you. I wonder if you could come out and take a look. So I went out there, and this is what I saw, this fire right here. And you can see this was definitely the point of origination. There was no question about that. What was confusing the fire marshal is the fact that this was a 24-volt lighting system. And he said, geez, you know, I obviously I know that electricity can start fires, but I thought that 24 volts was considered safe. And I explained, I said, well, 24 volts is considered safe from electric shock because 24 volts is not a high enough voltage to drive the amount of current that would be required to kill you. But when it comes to fire, it's not really a function of the voltage, it's a function of the current that's important, because the fire is relative to power. Power is I squared R, current squared times resistance. So yes, this was only 24 volts, but it was also 25 amps, and 25 amps squared times the resistance is quite a substantial amount of power. So yeah, this low voltage lighting system did in fact start a fire, and that is why the code exists, to prevent such things. This was an open splice. Whoever ran it kind of thought the way the fire marshal did, thinking that it was low voltage, so who cares? And unfortunately, that's not the right philosophy to have. So we have fire from electricity, and we also have electric shock from electricity. That's the other thing that we're trying to prevent. Now, this photograph seems unusual, and it certainly is, but it's real. It's not a staged photograph. This is a real installation, and we're measuring 113 volts, so essentially 120, from the metal parts of the faucet to the equipment grounding terminal on this receptacle. So anybody touching this could receive a fatal electric shock, and that's what the code's trying to prevent. This is not a code-compliant installation. In a code-compliant installation, you would never have 120 volts between the faucet and an equipment grounding conductor. Now, this photograph is, like I said, quite unusual, but it's not an unheard of scenario. In fact, this was the exact type of installation that resulted in the death of several U.S. soldiers in the Second Iraq Gulf War. There were quite a few young soldiers who were killed in the barracks due to this type of scenario. This is an actual news article from CNN. I think it was from 2008, if I'm not mistaken. And then you can see the part that I've highlighted. The water pump was not properly grounded, and when he turned on the shower, a jolt of electricity shot through his body and electrocuted him. And down at the bottom, the victim, age 24, was not the first. At least 12 U.S. troops have been electrocuted in Iraq since the start of the Gulf War. So that's what we're trying to address. These were not code-compliant installations, and unfortunately they resulted in dead bodies. And that's exactly why the code exists, to prevent this type of thing from happening. 90.1 also goes on to tell us that the code is not a design specification or an instruction manual for untrained persons. If you're at a point in your electrical career where you think the appropriate way of installing track light is to tape it to a beam, well, the code probably is not for you. You haven't gotten to the point where the code's going to help you yet because you're not a trained person. The code is not there for untrained persons. When I was quite young, when I was 18 is when I got into the trade, and I was told all along that understanding the electrical code and having a copy of the NEC was very much required, and having the code book was like a tool. It was part of being an electrician. And because I've always enjoyed reading, I figured, okay, well, every night when I go to bed, I'll just open up the code book and I'm just going to start reading the code book, and that was a mistake because I wasn't ready to learn the code book yet. I wasn't a trained person. The stuff that I was reading was going in one ear and out the other. I wasn't understanding it, and I was becoming frustrated with it. And that's because the code is intended to apply to trained persons. You have to have somewhat of a knowledge before you can really use and understand and apply the code. The code's also not a design specification. We don't tell you things like where to put your light switches in a house. That's not a safety issue. That's a design issue. So the code doesn't tell you how to do that. So yes, your design needs to comply with the code, but the code is not intended to design your building. It's a safety standard, and that's all that it is. In fact, the code even has kind of a self-deprecating statement here in 90.1b when it comes to adequacy. It says, look, complying with the code will result in a safe installation. But that's all that we're promising. It might not be efficient, convenient, or even adequate for good service or future expansion. This was at a meeting that I was attending. It was a group of electrical people. I won't tell you which organization it was, but there was not enough power in this meeting room. So we had all of these relocatable power taps daisy-chained into each other. Now, that was a pain, certainly, and it was not efficient or convenient or adequate for good service, but nobody died. It didn't burn the building down. Nobody died. It was, in fact, safe. This building complied with the code. There were enough receptacles, but it wasn't convenient. Well, that's okay. It doesn't have to be convenient. It just has to be safe. That's all that the code is guaranteeing. So in a perfect world, we would have had more receptacles through this meeting room. And in fact, in the 2017 code, in section 210.71, there might even be requirements for more receptacles in a meeting room. But those rules weren't in place at the time this picture was taken, or when the building was installed. So this was okay. But the bottom line is this was, in fact, safe. Might not be efficient, convenient, adequate, but it's going to be safe if you follow the code. There's an informational note that says hazards often occur because of overloading of wiring systems. So the initial installation should provide for increases and changes in the use of electricity. So as we can see in the photograph here, that's going to be an obvious hazard, and that's something that we should try to avoid by planning for future expansion and future use of electricity. It's an informational note, and that means it's really not part of the code. It's not an enforceable requirement, but it is good information. You should do your best to plan for the future. All right, 90.2, the scope. This is a really important section. 90.2a, installations that are covered by the code. What does the code cover and what does it not cover? Well, 90.2a says the code covers the installation and, new to 2017, the removal of conductors and equipment, including signaling, control, fire alarm, communications, and optical fiber. Let me get the removal part out of the picture since that's underlined and in yellow and it's kind of jumping off the page. The code really doesn't cover the removal of conductors and equipment, other than in a few very specific instances. If you go into the back of the code book, back into chapter 7 and 8, you'll find that for limited energy circuits, communication, coaxial cable, remote control signaling, optical fiber, fire alarm, if I have one of those circuits and I discontinue it, so I cut it at both ends, I stop using it, or I just undo it or turn it off, the code requires that I remove abandoned electrical cables, low voltage cables, communications, again, fire alarm, things like that. And it's not necessarily that the cables are unsafe. I mean, they're not being used. So if they were safe while they're being used, while they're energized, how are they suddenly unsafe when I remove the voltage from them? Well, they're not unsafe in and of themselves, but here's the problem. You ever opened a ceiling grid in a commercial building and seen like a massive wad of cables up inside the ceiling? Well, that in and of itself isn't dangerous until there's a fire in the building. If those cables were to somehow catch fire, it would spread along those cables throughout the building. And sometimes, in a high-rise building, for example, the high-rise building is required to be non-combustible, so we limit the spread of fire. And low-voltage cables are one of the few combustible items in a big commercial building. So when those ignite, they can spread fire throughout the building very, very quickly. So we want to remove abandoned limited energy circuits. But that's the only place that the code requires you to remove unused equipment. You don't have to remove unused EMT or 12 gauge THHN, MC cable, panel boards, switchboards, boxes. You don't have to remove any of that stuff. You just have to remove abandoned limited energy cables. But back to the topic. The code covers the installation of conductors and equipment. The word installation is critical here. The code covers installations. It doesn't cover maintenance. It doesn't cover usage. It doesn't cover upkeep. What you install needs to comply. And once you've installed it and it complies, then the installation remains compliant until somebody goes along and changes something. If I built a building in 1950 and it complied with whatever code was adopted at the time, then that building remains compliant to this day. If I go in and change stuff, then the changes that I make, the installations that I make, need to comply with today's code, because the code again covers what you install. Once it's installed, it's compliant, and it remains compliant until you mess with it, until you make another installation. Because again, installations have to comply with the code, but the code doesn't cover maintenance, it doesn't cover upkeep, it doesn't cover usage. You don't have to update your building every 3 years when the NEC is updated. Makes sense. So looking at this photograph here, this is a picture that I took at my son's gym. He's a parkour athlete, so he's into doing flips and jumps and all that stuff. And I was down there watching him work out the one day, and I saw this, and I thought, man, I got to take a picture of that. What a great code violation, because when you look at these relocatable power strips, they all have instructions, and they all say the same thing. They say, number one, don't plug them into each other. And then number two, don't mount them to anything. Don't hang them on a wall. Don't hang them on a post, which of course is why they all have mounting holes in the back. But so I looked at this and I thought, man, what a great code violation, because 110.3b says, hey, look, if you have listed equipment, you have to follow the listing instructions, and the listing instructions include the product instructions. So this is a violation. But then I stopped and thought about it, and I looked at what these cords were being used for. And none of it was installed electrical equipment. One of these was going to like a radio, and another one was going to an oscillating fan, to keep everybody cool while they're working out, and another one was going to like a portable light or something. None of this was really part of any electrical installation. So is this a code violation? No, not really, because this is not installed it's not an electrical installation. It's the usage of electricity. Let me give you another example. If I go to Article 400 and 400.12, it says that cords are not allowed to go through doorways, windows, walls, holes in the ceiling, things like that. So what happens when I'm vacuuming my floor at my house? I plug my vacuum into the hallway, and the cord of my vacuum goes through a doorway. Is that a code violation? I mean, the code says, hey, look, cords can't go through doorways. So is that a violation of the code? No. The code doesn't tell you how to vacuum your house. The code tells you how to install electrical equipment. So that's not a violation because that's not an installation. So in this photograph, I would say that the code probably ends at the receptacle. But that's not always the case. Here we have some installed electrical equipment, this garage door opener. That cord is regulated by the NEC because this is an electrical installation. That is installed electrical equipment. To be more specific, that's an appliance, Article 422. So this cord is regulated by the NEC, and it has to comply because that's part of an electrical installation. So the code doesn't necessarily end at the receptacle. Sometimes it does, but it doesn't always. Looking at this photograph, this is kind of a weird little do-it-yourself light and switch box thing with some NM cable going to a cord. If that was an installation, we definitely have ourselves a few code violations. But that's not an installation. That's something that some guy built in his garage and he plugged in. Now, is that a good thing to do? No, obviously not. And it might not even be safe. Is this a violation of the NEC? Probably not, because that's not an installation of conductors and equipment. That's just usage. It's not an installation. If I bolted this to the wall and bolted the switch to the wall, then we probably have some installed electrical equipment and the code would cover it. So the code covers installation and to a certain extent removal of conductors and equipment, regardless of voltage. Signaling, control, fire alarm, communications, optical fiber, all of these things are covered by the NEC. 90.2A1 talks about when the code applies, and really we can go through 90.2A pretty quickly now because the code covers everything. That's the way the code says. The code says, look, if you install it, the code applies, other than the exemptions in B that we're going to talk about in just a minute. So 90.2A, what's covered? Installations of conductors and equipment in public and private premises, including buildings, structures, mobile homes, recreational vehicles, floating buildings. So everything you can see in this photograph here is probably covered by the NEC. Code covers yards, lots, parking lots, carnivals, industrial substations. This stuff is covered by the NEC, unless 90.2B says it's not. Installations of conductors and equipment that connect to the supply of electricity. Again, the code covers everything that's installed, unless 90.2B says it doesn't. Even installations used by a utility, like office buildings, warehouses, garages, machine shops, and similar installations. This is a power plant where I teach. Most of the stuff in this photograph is actually covered by the NEC. When I'm teaching inside of this building here, and it's in a room that's probably not unlike the room that you're sitting in right now. It's got 120 volt receptacles, 277 volt lighting, Yeah, it has to comply with the code. Why would it not? When I walk in there, I go through a hallway, and, restroom, there's a lunchroom and everything else, there's offices. All of that stuff has to comply with the NEC. What does not have to comply with the NEC, what the code does not cover, is discussed here in subsection B. The code does not cover installations in ships or watercraft other than floating buildings. It doesn't cover railway rolling stock, the moving part of the train. It doesn't cover aircraft. And it doesn't cover automotive vehicles other than mobile homes and RVs. So this was a ferry boat that I was in, and I looked and there's this furnace, and it looks pretty similar to the furnace that's in my own home. If I put that in my house, if I put this light in my house, it would have to comply with the code. But if I put it in a boat, it does not, because the code doesn't regulate that. Now, that's not to say that wiring a boat is the wild, wild west and you can do whatever you want. That's not the case. There are regulations that cover that. It's just not the NEC. You'd want to get with the Coast Guard. They have regulations for wiring ships. Same, watercraft. Railway rolling stock, the moving part of a train, is not covered by the code. We don't cover airplanes, and we don't cover automotive vehicles. Somebody couple of years ago told me that they were going to be wiring a taco truck, and asked me, what are the code rules for wiring a taco truck? I said, no, there are no code rules for wiring a taco truck because 90.2b says that we don't cover vehicles other than mobile homes and RVs. Item 2, we don't cover installations that are underground in mines or self-propelled mobile surface mining machinery and its attendant electrical trailing cable. Easy for me to say. When you're underground in a mine, the code doesn't apply. You're in the world of MSHA. When you're above ground, the code applies. Item 3, installations of electric railways for generation, transformation, transmission, energy storage, or distribution of power. All right, so here's an electric railway. This is in Salt Lake City, Utah. This is the TRAX system, and a lot of major cities, of course, have these. So you've got the train, and we know the train is not covered by the code, the rolling stock. And what this item is saying is that the wiring above is not covered by the NEC either. Every half mile or a couple of miles, the train stops and people get in and get out, and there's train stations, and the train stations have lighting and kind of vending machines of sorts where you put in your money and you get a ticket. All of that stuff is covered by the NEC, but the actual power for the train is not, and the train itself is not covered by the NEC. Item 4, communications equipment that's under the exclusive control of communications utilities. If it's located outdoors, or if it's indoors in an area used exclusively for the communications installation. That's not covered by the NEC. What you're looking at here in the photograph is what's called a primary protector. And if I were to install that at a building, I'm not a utility. I would have to comply with the code. And the code has rules for primary protectors. 800.90, if I'm not mistaken, talks about primary protectors. So looking at this photograph, this may or may not be covered by the NEC. I know it's not because I took this picture and that's at my house. And that's Comcast that put it in. They are a communications utility. That equipment is outdoors. It's under their exclusive control, so it's not covered by the NEC. If I were to install it and I had control of it, then it would be covered by the NEC. The last item is item 5. Installations under the exclusive control of an electric utility are not covered if the installation is a service drop or a service lateral or metering equipment. Okay, now this part is actually fairly easy. The meter is not covered by the NEC. If it's under the exclusive control of the utility, the meter itself is not covered by the code. A service drop and a service lateral is also not covered by the code. Now, what's a service drop or a service lateral? And we have to go to Article 100. A service lateral is defined in Article 100 as the underground utility conductors between the utility source, so the transformer, right, and the service point. And they're not regulated by the code. Okay, well, I know what the utility source is. That's easy enough. So the transformer, right, the power source. But what's the service point? Again, a service lateral is underground, starts at the transformer, ends at the service point. So we need to know what the service point is so that we know what a service lateral is. Well, a service point is one of the most critical definitions in the entire NEC. And it's such a simple definition that it's difficult because it's so easy. And I know that sounds kind of dumb, but let me tell you what I mean by that. The service point is the point of connection between the utility and the premises wiring. The service point is where the utility says, we're going to end here, and now it's yours. That's the service point. Wherever the utility says it is. The service point could be this underground junction box in front of this house, this handhole enclosure. That could be the service point if the utility said so. The utility could say, hey, look, we're going to provide power to this handhole enclosure, and then after that, you deal with it. If that was the case, then the service lateral would go from the transformer to this underground junction box. The service laterals, we know, are exempt. Now, in this installation, it's more likely that the service point is at the meter socket enclosure at the house. Could be, might not be, but in this application, it probably is. So if the service point is at the meter, then the service lateral is the underground conductors from the utility source to the meter. Let's go back. These wires would then be a service lateral. If this is the service point, then that's a service lateral. And we know that service laterals are exempt from the NEC. So the service point is really where the NEC starts. Anything upstream of the service point, we don't deal with it. That's utility stuff. If the service point was this underground junction box, then that's where the code would start. The conductors that go from the handhole enclosure to the meter would then not be a service lateral. They would be underground service conductors. The code covers service conductors. Service conductors start at the service point and they end at the service equipment, which is the service disconnect, the shutoff, right? The first place you can kill the power. So the service point, it's important to understand where that is because that tells you where the code starts. Now looking at this picture, we know that the code does not cover service drops either. What's a service drop? A service drop is the overhead utility conductors between the supply source and the service point. If the service point is at the mast, and it usually is, then that would mean this is a service drop and it's not covered by the NEC. Those wires could be laying on the dirt and it would not be a code violation. Those wires could be right underneath a window and it would not be a code violation. Now, again, that doesn't mean that it's the wild, wild west. All I'm saying is that would not be a violation of the NEC. The utility is going to have regulations too. Right? They're not just going to do whatever they want. They're going to have rules. And the utility is probably going to have pretty much the same rules that we have. So can you put the service drop right under the window? Well, according to our code, the National Electrical Code, yes. But according to the National Electrical Safety Code, no. And that's the code that the utilities use for regulation. So these conductors right here, if they're upstream of the service point, they're a service drop and they're not regulated by the NEC. Now again, the service point can be wherever the utility says. The service point could be at this overhead transformer. And if that was the case, then that's where the code would basically start because the code covers service conductors. If the service point is at the transformer, then these would be overhead service conductors and they would have to comply with the NEC. But if the service point is at the weatherhead, then the conductors supplying it are not regulated by the NEC because that would be a service drop. Service drops are not covered. Service laterals are not covered by the NEC. All right, moving along. So 90.2 B5A said that service drops, service laterals, and associated metering are not covered. Neither are communications, metering, generation, control, transformation, transmission, energy storage, or distribution of power if it's installed on property that's owned or leased by the utility. This is utility stuff. It's having to do with transforming and transmitting power. This is a 500,000 volt line. That's not covered by the NEC. It's on property that's owned or leased by the utility. Or if it's on a legally established easement or right-of-way. So parallel to the street, we have a utility easement. Those overhead conductors are exempt. It's on a utility easement. It's not covered by the code. This is a picture that I took a few years ago. I was doing an inspection on a brand new house. Walked into the backyard and holy smokes, this is what I saw. I got a 230,000 volt transmission line right in their backyard. Well, that is probably a utility easement, and that's not covered by the NEC. We also don't cover installations of utility stuff that are by other written agreements. So we don't cover it if it's on public utility easements or rights of way, but there are some areas where you can't get those. If I'm in a national park, if I'm on an Indian reservation, if I'm on federal land, military bases, there are no easements and rights of way. So how do you deal with that? The code recognizes that, and it says, look, if there are other written agreements then the code doesn't cover it. So maybe at Yellowstone National Park, they write down an agreement that services and utility stuff does not need to comply, even though it may not be on a utility easement or a public right-of-way. We've also got an informational note in this section, and I think it's quite important, saying that, look, utilities are usually regulated by a public service or a utility commission. I have a friend of mine named Eric, and he used to work at a chemical plant in Houston, Texas, and I think they bought their power at 230,000 volts, I believe. The facility was multiple square miles. It was a massive facility. And they had 12,470, and they had 138 kV, and they had 26. They had every voltage under the sun. But the bottom line is, they had voltages that we would only consider like transmission voltage, very, very high indeed. And one time we were talking, and he wanted to know about the code applicability, and he said, well, the code doesn't cover us. And I said, oh yeah, it does. You're not a utility. He said, well, yeah, but it's high voltage. I said, it doesn't matter. The code doesn't have a high and a low voltage cap, right? It doesn't start at 30 volts and end at 15,000. There is no starting or stopping point. We don't cover utility installations that are transmission, distribution, etc. But you're only a utility if you're regulated by a public service commission or a utility commission. Who are you selling electricity to? Well, nobody. We're generating it and we're using it ourselves. Okay, well then you're not a utility. You're not regulated by a public service or a utility commission. It doesn't matter that you have 25,000 volts. That means nothing. You're still regulated by the code if you're not a utility. However, we do have 90.2C, and this is important. Special permission. The AHJ can give exemption for installations that are not under utility control, if it's outdoors or if it terminates inside nearest the point of entrance of the service conductors. Looking at this photograph, yeah, this looks like utility stuff, but it doesn't have to be. This could be at my buddy's chemical plant. They have a switch yard like this that is absolutely massive. So how do I deal with that as an inspector? We know that the code covers it. What are the rules for it in the code? We don't really deal with this very well in the code. So what we have here is 90.2C that says, look, the authority having jurisdiction can exempt the installation if they want to. What would I do as an inspector? I mean, seriously, I like to think that I know the code pretty well. But if this was in my jurisdiction as an inspector, and I was asked to go out and inspect that, I wouldn't even know where to start. And I'm not ashamed to admit that. I have no problem admitting my own limitations. I wouldn't have any clue what I'm looking at in that photograph. So I would exempt code compliance. I would look at that and say, you know what? That is really not what the code is for. So I'm going to exempt code requirements. I'm going to let you get with the utility, have them look at it, have them make sure it's safe, and let them sign off on it, and I'm cleaning my hands. I'm not even going to touch this thing. So the code does recognize that, so we can have special permission to exempt code compliance. So that's what the code covers and what it does not cover. 90.3 tells us kind of how the code works as a document. It says that chapters 1 through 4 apply generally throughout the code. So general, wiring and protection, wiring methods and materials, equipment for general use. These apply generally to all applications. And then chapters 5, 6, and 7, they supplement or modify the rules in chapters 1 through 7. So chapter 5 is special occupancies, healthcare facilities, hazardous locations, marinas and boat yards, things like that. They have special requirements due to their unusual locations. Chapter 6 is special equipment, things like swimming pools, fire pumps, solar systems, PV systems. Those are all special equipment and they have special requirements. And then chapter 7, special conditions. Backup power systems. So emergency, legally required standby, optional standby, 700, 701, 702. And then we have things like remote control and signaling in 725, fire alarm, 760. Those things are chapter 7. Chapter 8 is kind of its own little code book. It's an oddity. Chapter 8 is communication systems, and nothing in chapters 1 through 7 applies to chapter 8 equipment unless chapter 8 specifically mentions it. So let me give you an example. We know in 110.26 the rules for working space. We know that you might need 3 feet or 3.5 or even 4 feet in front of an electrical panel. 30 inches wide, not less than the width of the equipment. We need working space. That would also apply to a fire alarm control panel. That's Chapter 7, and Chapters 1 through 4 apply to Chapter 7 installations. Chapter 7 could modify those rules. Chapter 7 could say, we don't need 3 feet, we only need 2 feet, or whatever. Now, as it happens, it does not do that, but it could. But here's where things get strange. Chapter 8 is its own code book. Chapter 8 covers communications in 800. 810 covers antennas and satellite dishes, and then 820 covers coaxial cable when it's used for video. So, what kind of working space do I need in front of a telephone board? Telephones operate at 96 volts. So, do I need 3 feet in front of a telephone board? The answer is no, because that's Chapter 8. Chapter 8 does not refer back to 110.26, so 110.26 doesn't apply. Chapter 8 is its own little code book, unless it specifically mentions it. Chapter 9 is tables, which are used for raceway sizing, conduit fill, things of that nature. And then Annex A through Annex J is just informational. 90.4 enforcement, one of the most misunderstood sections in the entire code book. The code is intended to be enforceable by governmental bodies that have legal jurisdiction over electrical installations. All right. One of the big misconceptions of the National Electrical Code comes from that first word, national. People think it's actually like a federal law. It's not. It's not. It's just a book. That's all it is. It's just a book. It's not a federal law. It's not the 27th Amendment. It's not the 11th Commandment. It's just a book until somebody adopts it. So in my state, in Utah, the state legislature adopts the National Electrical Code as a law. Okay, well now all of a sudden it's a law, so now we have to follow it. But there are states that do not adopt the National Electrical Code statewide. The code is adopted in every state, but not by every state. It's adopted by my state, but in some states it's not adopted at the state level. It's adopted at the county level or the city level. And you can adopt the code however you want. You can make it more stringent. You can make it less stringent. You can rip entire sections of the code book out. In fact, you go to Chicago, most of Chapter 3 does not exist in Chicago. You can't use cable wiring methods. So AC cable, MC cable, NM cable, UF, SE, all that stuff, rip it out of your code book, and that's the Chicago code. Right? In Utah, we took out AFCIs, which I personally don't agree with, but it is what it is. So they took AFCIs completely out of the code in Utah, and then they adopted it. You can adopt the code however you want to adopt the code. So it's not a federal law or anything else. It's just however it's adopted, that's how it's adopted. It's intended to be enforceable by governmental bodies that have legal jurisdiction over electrical installations. We call that body the authority having jurisdiction. And in Article 100, I love this picture. Who do you suppose the inspector is in this picture here? We've got the 4 guys in hazmat suits, and then you've got, well, So who's the authority having jurisdiction, or indeed what is the authority having jurisdiction? It's an organization, or an office, or an individual that's responsible for enforcing the code. In fact, I think the code says it has the legal authority to enforce the code, or the legal responsibility to enforce the code. If you can perform inspections legally, then you are an authority having jurisdiction. I was an inspector for about 16 years in Utah. I worked for a city called Draper City for most of my career. In Utah, the state adopts the code at the state level. And they also have a law that says you have to be licensed to be an electrical inspector, and you have to be certified and all sorts of different things. So if you have the legal authority to enforce the code, then you're an authority having jurisdiction. So in Utah, we adopt the code, and we also have a state law that says every city or every county either must have a building department or contract the services of a building department. So the state really transfers the requirement of enforcement down to the city or county. And then the city or county, of course, the mayor is not going to be performing electrical installations. So the mayor is going to hire a building official. And the building official then becomes the authority having jurisdiction because they have the legal responsibility and the legal authority to enforce the code. Now the building official is then going to hire inspectors. The inspectors have the legal authority to enforce the code, which makes them an authority having jurisdiction. They're not the only authority having jurisdiction. Their boss is also an authority having jurisdiction. So the authority having jurisdiction is a bit of a tricky definition. It's a simple definition because it has to be, but it's also rather complex. It's complex enough that there's an informational note that says, look, when public safety is primary, the AHJ could be a federal, state, or local department or individual like a fire marshal, chief of fire prevention, health department, building official, electrical inspector, or others with statutory authority. So again, in most installations, at least the ones that I deal with, the electrical inspector and the building official, they are authorities having jurisdiction. There are some areas, though, that this does not apply to. At government installations, the commanding officer or the department official might be the authority having jurisdiction. I worked for Draper City for 12 years, but there was one building in Draper that I never entered as an inspector, even though they were always doing remodeling and different types of work, and that building was the National Guard building. I had no jurisdiction there. If I wanted to walk into that building, well, A, they would have thrown me back out, and B, if I went in there and tried to throw my weight around and tell them what to do, they would have said, who are you and why are you here? Leave. I have no jurisdiction there. That's federal property, right? So at a government installation, the electrical inspector might not be the authority having jurisdiction. In that type of installation, maybe it's the commanding officer. Maybe it's the Army Corps of Engineers. It could be different people. So the AHJ is the person or persons or entity that has the legal responsibility and the legal authority to provide inspections. It goes on to say that the authority having jurisdiction must interpret the rules. But I added here in the slide, I added interpret the rules when needed. You know, some rules don't need to be interpreted. When the code says secure your conduit within 10 feet, well, that means 10 feet. Not 5 feet, not 6 feet, not 15, 10 feet. You know, so there are things that do not need to be interpreted. There are things that do need to be interpreted, however. Saying that I can't use a particular wiring method if it's subject to physical damage. That has to be interpreted. What does physical damage mean? When is something subject to physical damage? That's not something that you could ever define. So the code says, look, somebody has to interpret that. Who interprets that? The authority having jurisdiction. The authority having jurisdiction is also responsible to approve or disapprove equipment and materials, and also decide on special permission. Special permission, by the way, is defined in Article 100, and that's the written consent of the AHJ. So let's look at this photograph for example. Here I've got some luminaires that are not listed. They're homemade, for lack of a better phrase. We've got some EMT bent into a gooseneck, and we've got a listed refractor. We've got a listed lamp holder inside of it. We've got listed conductors that go through the EMT, and we even have a listed lamp that threads into it. That's not a listed luminaire. 410.6 says luminaires have to be listed. So could the inspector, could the AHJ still accept this and use special permission? Sure. They could use special permission and say, look, I know that that's not listed, but I'm comfortable with it. I'm going to use special permission and I'm going to approve it. Could the AHJ disapprove it? Sure. It doesn't comply. It's not listed. So if the AHJ does not want to approve it, they don't have to because it doesn't comply. But here's the thing. If it complies with the code, the AHJ has to accept it. The AHJ does not get to write their own rules unless it's done through a legally adopted process. Right? We're enforcing this as a law. Laws have to be written in a legal manner. The 5th and 14th Amendment to the Constitution ensure due process. This isn't North Korea. The inspector doesn't just get to walk up and say, "Hey, I don't like that. I'm not gonna pass it." Well, what do you mean you don't like it? It meets the code. It complies. Hey, if it complies, the inspector has to pass it. Plain and simple. If it complies, it complies. So the AHJ, the authority having jurisdiction, they have to interpret the rules. They have to approve or disapprove equipment and materials and decide on special permission. Things like this. Are these cables bundled? I don't know. The NEC doesn't define the word bundled in any general sense, so somebody has to interpret it, and that would be the AHJ. If the inspector looks at it and says, yes, those are bundled, okay, well then they are, because somebody has to interpret the rules. The last sentence in 90.4 is an interesting one. It says the code might require new products that are not available when the code is adopted. And if that happens, products that comply with the previous version of the code are allowed. Okay, what we're looking at here in the photograph is an AFCI circuit breaker. They first came into the code back in 1999, and we used to use what's called the branch feeder type of AFCI. And then in 2008, they made a change saying, hey, in 2008, we need them to be the combination type AFCIs. And when that was all happening for a little bit, for a short time, it looked like none of the manufacturers were actually going to have a combination type available in 2008. So now what are we supposed to do? We can't wire houses because the AFCI doesn't exist? Well, no. What the code says is, look, if that ever happens, just go back to the previous version of the code and you're good. And the code has to do that. And it seems dumb because you read this and you're like, well, why does the code require stuff that doesn't exist? You know, the easy way to solve this problem, just don't write code rules for stuff that isn't there yet. Well, if you're a manufacturer, you can't dump millions and millions of dollars into research and development of a product unless you know that the code's going to require it. You know, you can't dump $50 million into research for AFCIs and trying to create anything and then just kind of wait and say, boy, I hope that passes the code. If it doesn't pass, we're out of business. So, you know, I hope it passes. Obviously, that can't happen. So, to my knowledge, we've never had to use this section. I don't know of any code rule that's ever been passed where the product didn't exist yet. But if that ever happened, the people who write Article 90 had the foresight to deal with that issue before it became an issue. 90.5 I'm going to hit really quick. Language. The words shall and shall not are requirements or prohibitions. If it says you shall do this, well, then you have to do it. If it says you shall not do this, well, then you better not do it. It's simple enough. Subsection B says shall be permitted or shall not be required are alternatives or allowances that the inspector must accept. It's actually, the code says that it's permissive language. Well, yes, it is permissive to the installer. It's not permissive to the inspector. The inspector has to accept it. Look, it shall be permitted. It shall be permitted. You will allow this. Or it shall not be required. Look, you will not require this. It's not required to do X, Y, and Z. So A is mandatory language speaking to the installer. B is mandatory language speaking to the inspector. Subsection C talks about explanatory materials. Explanatory material like references to other standards or references to related code rules. This is included as informational notes and they're not requirements. So for example, the code doesn't have, in any general sense, it doesn't have any voltage drop requirements because it's really not a safety issue. So 210.19a, there's an informational note. 215.2, 310.15, there's an information. They all talk about voltage drop and said, hey, look, it would be a good idea if you limited voltage drop on branch circuits to 3% and feeder circuits to 2% and a total branch circuit of 5%. But that's not a requirement. It's just information. It's just a good idea. Bracketed references are to other NFPA standards. Sometimes you'll be reading in the code and you'll see, like I have highlighted here, this bracketed reference. What 99:3.3.4. What is that all about? Okay, well, bracketed references are from other NFPA standards. So here in we got the critical branch here. This is 517.2, by the way, definitions. So this 99.3.3.39, that means that the definition of electrical life support equipment, that definition is copied from NFPA 99 and pasted into the NEC. More specifically, it's in NFPA 99, section 3.3.39. So that's what the bracketed stuff is all about. The last thing in 90.5 is informative annexes. Non-mandatory information can also be found in the annexes in the back of the code. Product standards, some example calculations to help you out, some raceway fill examples, type of construction, admin and enforcement, accessibility. These things are not mandatory, they're just information, so they're in the back of the code book in the informative annexes. We've got 90.6, formal interpretations. In order to promote uniform interpretation, formal interpretations from the code-making panels can be sought in accordance with NFPA regulations. Okay, this is not what most people think it is. If I call NFPA, because I'm an NFPA member, and if you're not, you should be, so I'm an NFPA member, I have a question on the code, I call my buddy Derek or Mark, and I call them up and I say, hey, what are your thoughts here on 210.8? And I want your interpretation. NFPA can give you their interpretation, and they're quite good. They're very skilled. That's why they have that job. But that's not a formal interpretation. Okay, that's the opinion of a very well-respected and well-educated individual. But it's not a formal interpretation. A formal interpretation has to be submitted formally in the form of a yes or no question, and it actually goes to the code making panel, and they publish the answer, and they put it in the code book. So for example, a while back, this would have been in 1981, that's how often they come around. It's not very often that anybody does this. Somebody asked the question, is it intended that fixtures, luminaires, installed in suspended ceilings be subject to the requirements of Part 10 of Article 410? Answer, yes. That's a formal interpretation. That means somebody wrote that and they submitted it to the actual code-making panel that covers Article 410, and the individual members of that code-making panel voted yes or no. That's why it can only be a yes or no question, and it's a big formal ordeal. So when somebody says, hey, I got a formal interpretation, no, you didn't. No, you didn't. I think there's I don't even remember the last time one was issued. 6 years ago? 9 years ago? Really. So a formal interpretation is not what you think. Yes, you can do it, and it's great that you can, but it has to be a yes or no question, and it is an actual formal interpretation. And by the way, the AHJ does not have to accept it. The AHJ might look at it and say, okay, cool, that's the interpretation of the people who actually write the code. I don't care. So it's a lot of work to go through for something that's not necessarily legally binding. Now, the code doesn't talk about this in the code. I'm going to throw it in here in 90.6 since we're kind of on the topic. Although it's not discussed in the code, errata can be found at nfpa.org. They're usually clerical errors, and the legal status of them is debatable. So, in other words, look, man, you're writing a book. It's a 1,000-page book about on the NEC. There's going to be some mistakes. There's going to be typos and weird little things. It's going to happen. When that happens, NFPA will publish an errata and say, oh, look, right here when it says 310.104, it was supposed to say 310.103. So, oops, our bad, we're sorry. It happens. It's written by humans. Humans make mistakes. Sometimes they'll publish something in the NEC that was not even supposed to be there. So in the 2017 version, there was a proposal to add an informational note to 300.4. And it said, hey, because that 300.4 is talking about physical damage. And there's a note that said, hey, minor damage to a raceway, cable armor, or insulation doesn't necessarily hurt the wire. It might just be aesthetic damage, and that's not an issue. And that proposal was rejected. It didn't pass. But somehow when they were actually typing up the code book, somebody kind of dropped the ball and they said, oh, cool, that passed. Let's put it in the code. And they published the code. And then somebody's like, hey, that proposal didn't pass, guys. That wasn't supposed to be in the code. And NFPA is like, oh, God, you're right. Oops. So in the second edition printing of the code, you won't have this informational note in your book. If you have the first edition of the 2017 NEC, you would have this informational note. It's not supposed to be there. So it happens. Mistakes, they happen. So that's errata. And there's also what's called tentative interim amendments. A tentative interim amendment is when a code change goes through the process and it passes and it gets put in the book, and then suddenly somebody realizes that it was a major screw up, like somebody's going to die, or this change that just passed might put somebody out of business. So we're going to issue what's called a tentative interim amendment. That's where somebody says, hey, boy, you made this change in Article 590 for temporary wiring that says you don't need to have boxes for your splices. Well, I think that was supposed to say on construction sites you don't need boxes for your splices. We don't want open splices at a Christmas tree lot or at an exhibition hall for a trade show. We're not supposed to have splices just laying on the ground. So yeah, that change went through, but it was a screw up, and people might die. So, again, the code's written by humans, and we're all doing the best we can, but we're going to make mistakes. So sometimes they'll issue an actual tentative interim amendment saying, look, yes, it passed through the code. It is in the code. We can't change that for another 3 years. But this is what we meant. We meant on job sites, you don't have to have a box for your splices. So you can find these at nfpa.org as well. They're considered emergency changes. Again, the legal status of it, I don't know. That's debatable. 90.7, examination of equipment for safety. This is kind of a surprising rule, or statement. It's not a rule. Some equipment in the code must be listed. Not everything has to be listed. And a lot of people think, how many times have you heard somebody say, well, you got to be UL listed? Okay, well, number one, nothing has to be listed by UL. UL is one company, one testing laboratory that lists equipment, but so is Intertech, and so is Met Labs, and there's a lot of different testing laboratories, so nothing has to be listed by UL. Some equipment has to be listed. Not all equipment. Just some certain pieces of equipment have to be listed. Listed equipment ensures that the product has been tested by a laboratory that's properly equipped to do so, and it removes the repetition and inconsistency of multiple inspection agencies. Looking at this photograph here, I like to think that I know the code pretty well, and I feel pretty confident as an inspector. But boy, I'll tell you what, I wouldn't want to look at this thing and have to figure out whether it's going to perform safely. I'm going to look for a label showing me that it's been tested and is listed by a testing laboratory. When I see that sticker, my heart kind of stops, it slows down, and I can look at it and say, okay, good. I know that somebody tested this transformer. It's not just going to blow up when they turn it on. You know what I mean? Because it removes the requirement for individual inspectors to test it. Plus, I don't really have the capability of testing this transformer. That's something that has to be done by a laboratory. So some equipment has to be listed, and when it is, that means that I don't have to inspect it. For listed equipment, the factory installed wiring and the construction of the equipment does not need to be inspected, except to check for alterations or damage. I'm not going to get out my magnifying glass and start sizing these conductors and making, is that THHN or is that XHHW-2? I don't care. It's a listed piece of equipment. I'm not inspecting it. I don't have to inspect it. I just need to make sure that what? It hasn't been altered or it hasn't been damaged. Now, can you alter listed equipment? Well, yeah, to a certain extent you can. And I know some people are like, oh, no, you can't. Well, yeah, you can. Think about it. When you buy a cabinet that you install a panel board in, do you buy a cabinet that has pre-drilled knockouts? Or do you like to drill your own? I always like to drill my own or punch my own. Well, once I start punching holes in the cabinet, didn't I alter a listed product? Well, yeah. Obviously, I altered it, right? If I don't alter it, I'm not going to be able to use it. So can you alter listed equipment? Yeah, to an extent. You just can't damage it. You can't change the functionality of it. You can't turn it from this into that, make it do something it was never even intended to do. So we have listed equipment, and then the AHJ is going to look at it and determine whether or not you altered it, changed it, damaged it, and if you did, then the AHJ is going to look at it and determine whether or not it's still going to be acceptable. So they'll look at the alterations or damage as a basis of approval of the equipment. Yes, you altered that luminaire. How did you alter it? Well, the screws that came with it, mounting screws, were 2 inches long. I cut them down to 1 inch and then I put them in. Did you alter the listed product? Yes. Did you alter it in a way that's going to matter? No. So I'm still going to approve it. So there you go. New to the 2017, and I'm paraphrasing here, it says for listed equipment, suitability of the product must be determined by applying requirements that are compatible with the code. So in other words, the fact that your equipment is listed doesn't negate code compliance. It still has to comply with the code even though it's listed. What we're looking at here is a listed electrical building. And inside of this, you're going to have a generator and a transformer, a main distribution panel, some panel boards, a motor control center, all sorts of electrical equipment, all pre-wired from the factory, set it in place, done deal. It still has to comply with the code, even though it's listed at the factory. And I don't have to, I don't have to inspect it, except to check for alterations or damage, right? I'm not going to get in there and I'm not going to check the wire size and everything else. But let's say that the panel inside of there is over 6 feet wide and it's 1200 amps or more. That might mean that I need 2 ways out of this building. I still have to provide 2 ways out. Whether it's listed or not, it still has to comply with the code. So that's what 90.7 is saying. It still has to comply. 90.8, wiring planning, kind of a weird statement. It's not a rule. Designs that give extra space or spare raceways allow for future expansion. Right. Distribution centers in readily accessible locations provide convenience and safety. All right. Good. It's not optional, right? Readily accessible locations for panels have to be in a readily accessible location, and it's not an option. So I'm not quite sure what this section really does. You could delete it from the code, and the code would be the exact same. 90.8b, the code limits the numbers of circuits in a single enclosure to varying degrees. This minimizes the effects from a ground fault or short circuit. All right, good. The last thing is 90.9, units of measure. I'm only going to cover subsection D, but suffice it to say that we use both the metric system and the SI system, the inch-pound method. We use the metric system first because the code's intended to be an international document and the US is a little bit backwards and we don't use the metric system for whatever reason. So 90.9D is quite important. It says, look, compliance with the numbers shown in either measurement is allowed, so soft conversion. If it says 2 meters and 6 feet or whatever that might end up being, compliance with either is considered compliant. So I don't have to stick with one measurement or the other. I can use metric or inch pounds. They both comply. All right. And the last thing is, thanks for watching. I hope you got something out of it. Hope you leave comments if you want to. Please feel free to, and we'll see you next time. Thanks.